Hi, good afternoon and welcome. Welcome to the webinar today, combined effort between Tyrell and swXtch. Today we're going to be discussing with our new partner, Switch, how we can truly unleash the power of cloud for live production. Before we get started though, a little bit of housekeeping. So within the Zoom software, there is a Q&A capability. So if you have any questions, please do write them down during the webinar, and then we can come to them later on at about a half an hour later. We'll get through to a point where we can have some Q&A answers. Before we dive straight in, let's wait a few moments and for more attendees to join the webinar. So we'll wait a few more moments. Cool. Okay, so we've got quite a few attendees now in the room. So let's kick off. So first of all, let's do some introductions. I'm your host today. My name's Nick Soper. I'm a cloud solution architect and also the product owner at Tyrell for our own cloud platform, Tyrell Cloud. I've been in the TV industry for nearly 30 years now, working as a vendor for both Avid and Telestream, along with being a reseller. And also I've jumped the fence where I was head of engineering for a major post-production house in London. So a broad scope of experience within the TV industry. But more recently, I've specialized in cloud, realizing the benefits that cloud brings for business agility for about the last 7 years across numerous different projects. A little bit info on Tyrell. So those that may be familiar, you may have heard this before, but those that aren't. So Tyrell is a 24-year-old systems integration house and value-added reseller. And we provide solutions into a broad scope of sectors within media and entertainment, ranging from production, post-production, broadcast, VFX, and animation. And totally, we service about 350 customers across UK and Ireland. That's the territory that we natively serve. Traditionally, we handle any workflow involving file or stream, and that ranges from contribution through to consumption, with production and distribution between the two. So in the last 3 years, we've been delivering projects as an AWS Select tier partner, and this is also whilst developing our own orchestration platform called Tyrell Cloud, for which I'm the product owner. And our goal really is to dilute cloud and fundamentally make it simple, make it attainable. Tyrell Cloud is a self-service orchestration platform built on AWS, as we say, and it's built to deliver on-demand HP Anywhere integrated workstations, edit share file system shared storage, and also has an ability to ingest SRT streams, delivering them into the range of workstations and essentially bringing that streaming medium into your virtual machine room. And all of schedulable using our custom scheduler that comes as part of our management platform. So back to the webinar today. I'm very excited about today because there's a whole load of information we're going to share and talk through in terms of what Switch can bring to the market. So I'm joined today by Patrick McCoy and Cassidy Phillips of swXtch, and together we'll be discussing how we can break the barriers of live entry for production in the cloud. Pat, Cassidy, would you like to take a moment to introduce yourselves?
Sure. I'm Patrick McCoy. It's great to be here. I am head of product at switch.io. Been with Switch now for over 3 years. The company is about 4 years old. And I come from a background, a media and entertainment background, 25 plus years on the technology vendor side, creating playout and networking products. And so joined Switch to bring multicast and cloud migrations, the ease of cloud migrations to all of the clouds, AWS, Google, Oracle, and Azure. Um, switch.io was created to make cloud networks better, and we'll talk a lot about what some of those features are that we bring to the table that makes your cloud network look just like your on-prem network.
Cool. Sounds
Great to
great.
be.
Thanks, Pat.
Yeah. Cassidy Phillips. I'm the Director of Customer Solutions for Switch. We're a small company, but my team of solutions architects handles all sort of design engineering, tech support related things. I have over 20 years in the industry as well, 13 of which were on the operations side and master control for national and international programming. Um, I also did over 40 SMPTE 2110 systems on-prem, and that's actually what led me to start talking to Pat and Switch about joining their team, because we know these 2110 systems were then looking to grow beyond the brick and mortar limitations and connect multi-site across the globe through the cloud. So I was sort of investigating solutions, and I thought, well, that sounds really interesting. I'd like to be a part of that. So I joined the Switch team.
Fantastic. Cool. Well, good to have you both here today. Thanks for joining us. So, jumping straight in, obviously during your intros, you made some brief summary statement about Switch and things, but let's start right at the top. So, why cloud for live production? Doesn't that add much more difficulty and complexity?
Go ahead, Pat.
Yes, I mean, it's no different with our Cloud Switch product. It's no different than really in an on-prem environment. One of the key challenges that customers or, media and entertainment customers have is utilizing on-prem and cloud together to create these hybrid workflows. And one of the key features missing out of there is multicast and reliable transport. So multicast is something that we create inside of the cloud that connects your on-prem network to your cloud network. That way you can create your workflows and your workloads, whether it's on-prem, in the cloud, or some combination of the two together.
Perfect. So the fear of taking production to the cloud should really be set to one side now. Looking at those bullets on the slide, it offers a huge array of flexibility and agility. So it's something not to be afraid of any longer by the sounds.
Yeah,
Yes.
I would agree. Yeah, if you're talking to the right people, namely us, we can help you eliminate those barriers. Yeah.
Cool.
Uh,
Okay.
yeah, absolutely. And I think, Pat, if you want to go into, multicast is just a part of it. And why is multicast important, right? I mean, I think sometimes people don't even understand how multicast is so integral to 2110 or some of these other things. So, there's aspects to that as far as multicast versus unicast that I think are worth digging into a little bit, Pat.
Yeah, that's great. I was actually going to ask the question. You're jumping ahead now, guys. But so how does multicast help? Obviously, it can help in terms of cost, but what other benefits can multicast bring?
Yeah, from a operational perspective, multicast is really important. In an on-prem environment today, for example, I think you take multicast for granted because it just exists in all of the networks. And when you're, say, a playout server or a multi-viewer and you want to get access to a stream, then a simple standard IGMP join can get you that stream. And that's how 2110 is built today on top of multicast. And most workflows in broadcast environments are built on top of multicast capability. And so that was the opportunity we saw to bring multicast into the cloud, along with high bandwidth and low latency. This is one of the key aspects of our solution as well. Obviously, in these live production type of environments, you need to bring in high bandwidth flows from live events such as stadiums and cameras and trucks, etc. And having the ability to bring in uncompressed video reliably from on-prem into the cloud so that you can process these production workloads is really important. And of course, low latency. Everybody knows that latency is really important in live production environments.
Absolutely. Cool. Okay. So there's obviously a difficulty in handling multicast in the cloud, and this is where the product Cloud Switch fully caters for that requirement. So forgive me, why hasn't this been done by the hyperscalers themselves, like AWS or GCP and Azure?
That's a great question. AWS has something called Transit Gateway that has some multicast capability, but it's not really appropriate for media and entertainment because of high bandwidth required by media and entertainment.
Hmm.
Google, Azure, Oracle, all the other clouds, they have no multicast capability. It's primarily due to the size of these cloud networks and the technical difficulties with implementing a multicast network across this entire hyperscaler. And so they just don't do it. We've talked to their networking teams, and they are staying away from that because of the technical difficulties of it.
Okay. Okay. Cool. Fair enough. So, I'm sure many attendees today on the call will be familiar with latest protocols and what's required in this IP-dominated environment. But I'm sure there are going to be specific protocols or specific functions that people maybe not aware of or overlook. Things such as PTP, as you mentioned, Cassidy earlier on, 2110, and even NMOS. So where does Switch fit into those scenarios?
Yeah, I'll speak to that a little bit. So what you can see here is a diagram showing just a kind of a mix of different things we can support, and we fully expect there to be environments that look like this. I'll break down the color coding a little bit, but the orange, the switch orange, is what I would refer to as multicast, and then what you see as red and blue, that's actually SMPTE 2022-7, and then we have green, which is my SRT color, and the lighter blue is wrist. So what we can do, in addition to just being sort of a virtual network switch, is we can support legacy protocols that people use to get in and out of the cloud or through the cloud today. So particularly when you have a production workflow where you have, say there's an endpoint that can only understand SRT as its transmit or receive, or maybe you have a business to business relationship where you have control of your environment, but you don't control their environment, and you have different networks, different addressing and everything, then SRT is still going to be used between those. So we have the ability to change protocols. So we support the multicast, which would have your 2110, your JPEG XS TR08 as 2110-22. But we also can support these legacy things or unicast, and we can change between them when you need us to. We've also done testing where we've seen NMOS work. So if you do 2110 or 2110 with JPEG XS, we make the network look as if it's all in the same facility or the same campus, the same virtual network. And what that means is that you do an NMOS ISO4 discovery, and your live production system is going to see endpoints on-prem and in the cloud as if they were all in the same place, which means that your router panel, and as Pat discussed, it's using multicast under the hood. Your router panel, when you say destination, graphics in the cloud or whatever it is, and you say source camera one, which is somewhere on-prem at the stadium, that's actually going to be the graphics engine sending an IGMP join. And so it'll just subscribe to a new multicast. And that can be anything connected through that virtual network.
Okay.
And that's no different than what happens in an on-prem network. And I think that's one of the beauties of our solution is that, as I mentioned earlier, we kind of span the on-prem and the cloud networks together with this one multicast network. So as Cassie was alluding to, NMOS can work across the cloud and the on-prem side simultaneously. And one other point to make about this diagram is these endpoints that are, a playout server or a graphics inserter, their software doesn't need to change at all in order to work with Cloud Switch. So if you have a virtual solution of a playout server or whatever on-prem or a multi-viewer or monitor, then you can deploy that in the cloud and no software change it will work with CloudSwitch just via standard IGMP joins and leaves.
Wow, I think that's an incredibly powerful statement. The ROI and the value on your existing infrastructure, your skill sets, your teams, your operations can carry over seamlessly. I think that's terrific. Incredible. Okay, that's great. So, in terms of obviously, there's lots of lines coming in and out of the cloud here. So, what type of connections can you, or what type of connections, let me rephrase that, do you require to be able to use CloudSwitch in these environments? Do you have to have a direct connect, or could you use on demand equally as well?
So great question. We've done a lot of work with customers and tests with public internet connections, with direct connect connections, even multiple cloud switches in a cloud going from region to region. And really, the only requirement we have is IP connectivity between two endpoints, the cloud switch and whether that's the on-prem side where our bridge resides or an endpoint like a multi-viewer inside of the cloud. And so, we've tested all of these different environments for different loss characteristics, latency profiles, and that sort of thing. So we work across a wide variety of ranges of those types of interfaces between on-prem and the cloud.
It's probably worth touching on lossless here a little too, Pat. We'll go deeper into it probably later on, but we know SRT works for a lot of things, right?
Mm.
But when we went to do higher bandwidth flows in particular, and again, that live production workflow where you have uncompressed video, maybe even, and low latency requirements there, some of the legacy protocols just were not delivering in a way that would probably allow for a multi-site live production to take place. So go ahead and talk about why we created lossless and what it actually does, Pat, or what we've seen it do.
Yeah, some of the, we've done a lot of interoperability tests with vendors and customers, and we've deployed in a production environment our lossless UDP, it's kind of like an ARQ mechanism, but it's transparent to all of the applications. It's transparent to the workflow. It's transparent to the on-prem environment, which is, one of the value propositions we bring is that you create your workflows like you do in an on-prem environment and let the network do the work for you. Let it do the 2022-7. Let it do the retransmissions under the covers. Let it do the multicast so that you have a good solid network upon which you can build workloads and workflows. And so, we've done some testing with, Cassidy, 70 some different vendors utilizing our cloud switch, our bridge, and our lossless UDP. So it's a great solution. And one of the beauties, as Cassidy referenced, was the high bandwidth aspect of this. We've tested in this JPEG XS interop where we were sending, these are 400 meg streams JPEG XS that from all these different vendors on-prem side into the cloud, where we were then delivering that to various endpoints that you see on here inside the cloud, ATEM, AWS Elemental, TAG, and Grass Valley. And so they were all utilizing the lossless UDP protocol, and they didn't even know it. They didn't have to do anything. None of the endpoints. We handled all of that under the covers. And Cassidy was actually at this interop. You might want to describe the process that we went through, because I think it's instructive as to how seamless it works.
Yeah. Basically, just we set this cloud environment up, Nick, without telling anyone what we were doing, and so they built the on-prem network and some of these elements deployed in the cloud. And basically, we just had to say, hey, run a curl command to pull our virtual NIC to your application's machine, and then you're going to be able to communicate with IGMP. And they did that. So one of the things we did was built up a multi-viewer with this tag multi-viewer in the cloud, and then we put it to a monitor. We were all in a production control room together for this plug fest, as you might call it. And everyone says, oh, there's the multi-viewer. And then we got to tell them, well, Yeah, it's not the multi-viewer here on-prem. It's actually a multi-viewer in the cloud. And that was an eye-opening experience for everybody in the room. I was really happy to be able to see it live.
Certainly, sure. So obviously there's an entry point into the cloud, and it sounds very much more like the cloud can now be that logical extension. So what elements of switch.io need to be on-prem? Talk us through that component or that connectivity. Is it a component specifically?
So there are, yeah, three pieces to the Cloud Switch overlay network. One is the Cloud Switch in the middle here that resides on a VM inside the cloud in the customer's tenant. There's on the bottom left, you see the X logo there. That's what we call our Cloud Switch bridge. That's the other end of the lossless UDP connection. That is a physical server in which we push our software to from the Cloud Switch to that physical server. It's nothing fancy. It's a 16 core, 10 gig, 25 gig NIC, whatever is required from a bandwidth perspective.
Mm-hmm.
And then the third element is the XNIC that Cassidy alluded to, that the ATEM, the AWS Elemental, and the tag and Grass Valley would have deployed onto it, such that that multicast network from the tag all the way, say, to the TVU or media links on the on-prem side can work.
Cool. Got it. Okay. So obviously there's an element of some complex networking, and as you alluded to earlier on, Pat, latency is usually on the tip of everyone's tongue. So in terms of your capabilities, what can Cloud Switch offer in terms of latency and performance? So you've got that seamless experience between geographies or between cloud and on-prem.
Yeah, that's something we've been working really hard on. We're really focused on high performance, not only on the bandwidth side, but on the latency side. So, the latency is really going to be dictated by the link between the bridge and the Cloud Switch. And so with customers in production today, that ranges over a direct connect, that ranges from one way, say 5 milliseconds, 5 to 10 milliseconds, which is pretty good. We've seen public internet type of applications up to 30 milliseconds of latency across that link. And in region to region, it's somewhere in between. So if you had two cloud switches, US East, US West, that kind of thing is somewhere, say 20 some odd milliseconds. And the dwell time, just one other point, in the switch itself, as packets are, the multicast packets are flowing, is in the single digit microseconds. So we're not really incurring any additional latency as the process of going through the switch.
Got it. So there's no concatenation as the switch is passing to and from. Okay, cool. Okay. So in many of our projects, managing streams in the cloud is hard. And we found that because if you take streaming at an abstracted level above the VPC, it's more of an application layer rather than just purely network packets. So do you bring, as well as the Cloud Switch, do you bring any sort of observability tools so people can realize and understand what's flowing where and when and how?
We do. We have a user interface called WickedEye, and it's a great tool, and it's again one of the things we work hard on to provide this observability inside the cloud, because today we get a lot of feedback from customers, saying that once they launch a stream into the cloud, we don't know where it goes, what's happening to it.
Yeah.
And by virtue of our XNICs that are deployed at each one of these endpoints, so if you see the Cloud Switch here in the middle and all these satellite, there's a playout server, a graphics inserter, a multi-viewer that's on here. These all have our XNICs on them. And what that gives us is kind of a network topology in which we can peer into any part of the network between any of these endpoints. And on the left-hand side is our bridge, and of course, far left side is the camera source. So at every point between two nodes, the bridge and the switch, and an XNIC and a switch, we have the ability to monitor what's happening. And so this gives great insight into, if you're having network issues, or in a workflow where you're going between three different workloads in series, you can pinpoint where problems might be. Is it between the bridge and the switch, the bridge and the switch and the multi-viewer, the switch and the graphics inserter? You have that ability to see all those things.
That's amazing. At stream level rather than just at packet connection level. That's brilliant. Okay.
Yeah, and
I think as an operator, this is one of the views I probably would have used a lot, right? The
Yeah.
life of the workflow. So go ahead, Pat. Tell me. I know you're
No,
starting to. Go ahead.
yeah, I know you. This is something an operator like you, Cassie, would have loved to have. This is a similar view. It's the same workflow that we saw in the previous slide, but it's a sequential view, if you will, of the stream as it leaves the camera, hits the bridge, the switch, and then the playout server, the graphics inserter, and then the multi-viewer. Here this is where you get the view in series as to what's happening. So while there are four cloud switches represented on this diagram, there's really only one switch in this implementation, but it's a way of allowing you to peer into the network and see what's happening between every workload that's transforming this stream.
Okay, got it. So seeing this life cycle of streams and obviously understanding your latency capabilities, some real world workflows that could be compatible with switch intercom potentially, or even taking things in reverse from cloud back down to ground. How do we see intercom landing on top of the cloud switch?
Yeah, that's a
So
great question. So I'll let Pat. Pat was
go
deeply
ahead,
involved
Cassie.
in the actual deployment, but this is a multi-site, multi-venue international sporting event that, billions of people watched. You can guess at what that was.
Yeah, rough idea.
Um, and they were having issues communicating with each other over the intercom because every time they pushed the button on their waistband, it took a variable amount of time, usually 10, 15 seconds to actually join the conversation, which when you have a director trying to ask a camera person for a different shot, that's just not functional, right? So go ahead, Pat, tell them what we did.
Yeah, so the implementation they used in AWS was, as Cassidy said, the latency, not only was it long, but it was variable. And as most people know, a variable latency is one of the worst things that you can have, besides being long. And so they were looking for solutions. This is just a couple of weeks before this event in the summer. And we deployed our cloud switch as a test with our partner here, Telos. And we, right out of the box, it was around 250 milliseconds of latency between the push to talk and when you would hear it. So it worked perfectly for them. And not only have they used it during this event, we kind of saved their bacon at the end, but they've now expanded the deployment of this for all of their intercom solution.
It's a great example of these types of assets, Nick, not requiring a truck to be moved in or racks of
Indeed.
equipment to be purchased, right? That's exactly what the cloud is for. So there's no way we could have done this as quickly with any other, medium of technology. I see someone named Dan Muchmore raised his hand.
Yeah, I saw a question then.
I needed in on this. I have two questions that are specific to this subject that have come through. One is, how do you measure latency? And then more in line with the conversation on intercom, if you can pass comms across switch.io, can you also pass audio stems from the consoles? So for example, mix minuses across the network as well. So latency and standard audio.
I'll do the first part, Cassie. You can handle the second. Those latency numbers that I was referencing, whether it was across a direct connect or a public internet or region to region, they were done from the receiver's perspective in round trip time, and we did it again on the transmitter, both the receiver and the transmitter side, with a round trip time divided by 2. That's the one-way latency. We created histograms over, and the average latency, as I mentioned, was around, for a direct connect was between 8 milliseconds or around there, where the variability on a direct connect is very small. So it really depends on the link that you have. The public internet obviously is going to be a lot different. So it really depends on the quality of the link that you have and how much bandwidth you're pushing through.
Cool.
Yeah. And as far as the second part, I fully expect people to use the cloud as sort of a dynamic media hub. So, you have these different facilities, and then the cloud ends up being the centralized place for all that media. So whatever it is, no matter what, whether it's uncompressed video or whatever audio it is, if it's packed into, SRT, or if you want to do it as multicast and run through our lossless, you could absolutely put all of those things into the cloud and then have something there, whatever application you prefer, acting as the mixing board or the place where you're making decisions about what audio is going out. One of the examples when I look at this laptop in the upper right is I think about maybe someone who's doing alternate language commentary, and they could be anywhere on earth, right? They could be at home, and then they're just dialed in to the same cloud switch. I say dialed, but it's not a phone line, right? They're actually connected through the internet today. And so you could do anything with video coming from anywhere or audio coming from anywhere. And I really expect it to be used in that way as we move forward.
Okay. Just jumping back to the latency question, and this is something that's close to my heart in terms of a recent project we've just closed off that's ultra low latency streaming. Can WickedEye actually help present the numbers in terms of latency from a packet through the network or a stream from the ingest point right the way through to that serial chain? Is that possible as a measurement or as a metric that you can present?
We don't have that implemented yet, Nick. It is something, you're not the first person to ask that, but we're have an active development on that so that
Okay.
you can, from the exit of one node to the entry of the other node, how long did this take? And you can do that all the way through the chain. And that's something that we're actually implementing right now.
I think that would be fantastic, because the traditional way is burning timecode in picture and referencing some sort of time clock. And if we could all walk away from that old 20th century workflow, that would be great. So, okay, good stuff. So just, we're conscious of time towards the end where we've got more time for questions as well. Are there any significant, so I'm obviously, as I said, 30 years in TV, and the vendors I've worked for are both very well known for their integration partnerships. Are there any particular partnerships or integrations that you have that are close to the core product or offer an extension to the product for that extra value push?
So there's two answers to that. Well, I think I mentioned earlier that we've integrated with about 70 different vendors, and so no real software change is required, to integrate and use the cloud switch. All of these vendors that you see on this diagram just integrated straight away with our cloud switch, and we were passing streams to and from them. Mm-hmm. Then there is the deeper integration, which we've got a partnership with Cinefilm, and on our cloud switch with their Tachyon Live product. You may be familiar with their file-based product, which is a standards converter. We've taken their standards conversion and applied it to streams that are traversing our cloud switch. So we can do in-network standards conversion with HD, UHD, back and forth, 50 hertz, 60 hertz, motion compensation, all that good stuff. They do a great job. Cinefilm does with their standards conversion, and that's tightly integrated with our cloud switch to minimize that latency, that traversing the network.
Yep. So as Cassie mentioned, it becomes truly a cloud hub for media, looking towards the Media Labs 2030 vision.
Oh, yeah, absolutely. You could have something created, where what we would think of as sort of the mezzanine or the master version is UHD, and then you put it into the cloud, and you could get out your different HD versions, different frame rates, and go off to your affiliates or business partners in whatever format they need from that central hub.
Fantastic.
I think it's also a good point to mention that we were starting to get deeper into containerization, right, Pat? I know that's sort of become a buzzword, and the idea of sharing machines for different workflows.
Yeah,
This is something we've already dipped our feet into.
Okay, interesting stuff. So last question from me, and then we'll open up the floor to any other questions from the attendees. Obviously, key elements of adopting cloud is being redundant, resilient, and fault tolerant, and all those lovely adjectives that essentially cost a whole ton of money. Can CloudSwitch help with that if a organization chose to go with different hyperscalers as partners?
Absolutely. We're on the marketplace in 4 different hyperscalers. 3 of them are on this diagram. Oracle would be the 4th. And we've actually done some POCs and tests with tier 1 customers who want to do just what you said, which is, I don't want to put all my eggs into AWS. I don't want to put all my eggs into Google or Azure. And our cloud switch, 2 cloud switches could be deployed, one in each cloud, or one of our endpoints, and XNIC could be in a 3rd cloud. As long as there's IP connectivity between our switches and our XNIC and our bridge, it doesn't matter where they are. And
Right.
that's one of the beauties about our solution. One of the value propositions is it looks the same regardless of which cloud you deploy in, which is great from an operational perspective. You don't have to relearn, well, in Azure, it's got to work like this. AWS, it's got to work like that. That's not true with our switch and our XNICs and our bridge. They all behave the same regardless of cloud.
That's great. Fantastic. That really does, again, break down that another barrier, doesn't it, for that risk mitigation discussion that we often have to have.
Oh yeah. Well, what's your paranoia factor is what I like
Exactly.
to refer to that as, and one of the interesting things here too, with this sort of wild diagram is our XNIC can deduplicate from up to 8 paths. So these could all be different streams that are copies of the same media, right? Could be the same media with just different multicast addresses. And the XNIC could actually deduplicate from all of those. So this is all hot all the time, right? There's no failover. There's no AB failover triggering happening. It's 2022-7 hitless packet merge. So it's just cherry picking the best packet off the best stream all the way through completely live.
Wow. Perhaps that could have been used for a most recent boxing match potentially, but we won't go there today, shall we? Let's not criticize. Fantastic, guys. Thank you very much indeed. I think let's open up the floor to some questions. Dan, are you fielding any questions from the audience, or have we been so compelling and comprehensive there are no questions?
I think you've been very compelling. There is actually one question open, and that's the commercial model of Switch. How's the product structured? How's the commercial side structured?
So we are, as I mentioned earlier, on the marketplace for 4 different clouds, and the model is pretty much the same for all of them, in that we charge by the month. We usually come up with annual contracts, and it's a monthly charge for the cloud switch, the virtual machine that you deploy. So there isn't a charge for bandwidth or any variable charges at all. You can think of it as buying like an Arista switch or something. Once you buy it, it's yours, and you pay that monthly fee, and then it doesn't matter how much traffic you push through it, and so you can size the VM to your needs. And so we have 3 different switches. Think of it as a small, medium, and large, depending on how much you want to push through it.
Okay, got it. That makes most
I think
sense.
one of the things too there is the same way we can be flexible with software and with these virtual networks. What Pat talked about with the monthly versus the year long or multi-year. It's really, we can be flexible with what people need to do in their business, right? It's as much as people talk about, oh, I might use this for 2 days and then turn it off and whatever. In reality, that's kind of hard on procurement or purchasing. So we can help.
Cool. No, I think it's really interesting because what we've been seeing more recently is a requirement for the alternate view on outside broadcasts and live productions. There is always the inevitable build-up and dry run dress rehearsals. But then at the end of the day, then you turn the infrastructure off. You don't have to pack any flight cases or condense a truck down and get rolling again, which is great. So that monthly model is very accommodating. But I think what we would like to do, obviously, is extend the commercials and partner that with Tyrell's own cloud capabilities. I know very recently we've built our team over a number of years in terms of cloud deployments with consultancy services and also DevOps for deployment and post-sale support as well. And knowing that the capabilities of Switch, one of our most recent major projects with our team, we've now been delivering, and this is a number to be astounded by, 5.7 million minutes of content a day, which is ferocious in an ultra low latency context. And if I was winding back to the start of this project 3 years ago, I wish Switch were around back then, but that's 2020 hindsight, because it would have made things a whole lot simpler. So, folks, thank you very much indeed. I think that the looking ahead to future projects, is very exciting. The galactic data plane. I think the limitations have been removed, and I think if there are any further questions, please do get in touch with Tyrell or the guys from Switch. As I say before, we have a very capable cloud DevOps team within Tyrell for these projects, breaking down the complexity of deployment, because people think it's very simple and straightforward, where actually it may not be if you need to iterate and change or extend. So again, thank you very much indeed. And really, I think the next time we will see each other will be face to face in London, won't we? So for our
Cool.
in-person event in Soho, can't wait for that. So thanks again, guys. Really enjoyed the time together today. And let's have a beer when we meet up on the 5th.
All right.
Again.
Thanks for having us.
Thank you, Dan.
Cheers, guys. Take care. Bye-bye.
All right.